The Yankee Rowe nuclear power plant in western Massachusetts was one of the first commercial nuclear plants built in the United States. After 31 years of safely and reliably producing electricity for New England consumers, Yankee Rowe permanently shut down in 1992, and the following year, decommissioning began. Decommissioning is a two-step process that removes and disposes of radioactive and non-radioactive components and material and cleans up radioactivity that may remain in the buildings and on the plant site. This cleanup process will allow the site to be used for other purposes after a final radiation survey demonstrates that decommissioning is complete and the facility meets federal regulations for release. But there is still one major hurdle to fully completing decommissioning and making the Yankee Rowe site available for reuse. There are 533 used nuclear fuel assemblies, similar to the model shown here, that must be carefully stored and protected until the federal government removes them to a centralized facility, such as the proposed repository at Yucca Mountain, Nevada. The fuel inside these assemblies, which is in the form of solid ceramic pellets, became highly radioactive after being used to produce electricity. The fuel assemblies, which have been stored in a protective pool at the plant for more than 30 years, are being moved to a different type of storage called dry cask storage, which protects the fuel in massive steel and concrete casks. This system allows the storage pool to be decommissioned and dismantled, and packages and prepares the fuel for eventual shipment to a federal facility. Yankee's dry fuel storage system was designed, licensed, and constructed by NAC International, a Georgia-based company with worldwide fuel handling experience. NAC is also conducting the fuel transfer from wet to dry storage at Yankee Rowe. With NAC's dual-purpose system, the fuel is placed in an airtight stainless steel canister, which is designed to fit inside the massive steel and concrete storage casks and also inside a specially designed transport cask for shipment when a federal repository is ready. The Yankee Rowe fuel storage facility will have 16 fuel canisters inside 16 steel and concrete storage casks. Transferring the fuel from wet to dry storage begins by placing the empty fuel canister into a transfer cask that provides radiation shielding. The transfer cask, with the empty fuel canister inside, is lowered by crane into the spent fuel pool. One by one, the used fuel assemblies are placed in the fuel canister. After the fuel canister is loaded and still in the spent fuel pool, a shield lid is placed on top of the fuel canister. The fuel canister and transfer cask are then removed from the pool to a special area where the fuel canister is decontaminated, the shield lid is welded, and then the canister is vacuum dried and filled with inert helium gas through ports that are later sealed. A structural lid is then welded in place. The sealed fuel canister is then lowered through the transfer cask into a larger steel and concrete storage cask, and another lid is bolted in place.
Now that you've seen how the fuel transfer process works, let's see how it was done at Yankee Rowe after fuel transfer operations began in June of 2002.
For each of Yankee's 16 transfer operations, the process begins by placing a 13-ton fuel canister, which holds up to 36 fuel assemblies, inside a 40-ton transfer cask and filling it with water. It is then transferred by crane from the fuel transfer enclosure building to the spent fuel pool building, where it is slowly lowered to the bottom of the spent fuel pool. The outside of the transfer cask is sprayed with clean water to minimize any fixed contamination on its surface while in the pool. Using underwater video cameras, robotics, and an overhead crane, the used fuel assemblies are slowly placed, one by one, inside the fuel canister. It takes about 15 hours to load one canister with 36 fuel assemblies. Once loading is complete, a 2.5-ton steel shield lid is lowered into the pool and placed on the top of the fuel canister. The loaded fuel canister, with the shield lid in place and still inside the transfer cask, is lifted out of the pool and transferred by crane back to the fuel transfer enclosure building. Inside the fuel transfer enclosure building, the shield lid is welded in place by a remote welding machine. Special ports on the shield lid that are later sealed allow the fuel canister to be dried and injected with helium. The canister is then tested to ensure it is airtight before a second 1.5-ton structural lid is welded in place. While still inside the transfer cask, The sealed fuel canister is lifted out of the fuel transfer enclosure building and placed on top of a 60-ton steel and concrete storage cask. A special adapter plate placed on top of the storage cask hydraulically opens the bottom doors of the transfer cask, allowing the fuel canister to be lowered by crane into the storage cask. The adapter plate is then removed, and a shield plug is inserted, followed by an outer cover that is bolted in place. The 110-ton loaded storage cask is then slowly transported to Yankee's dry fuel storage facility using a heavy-haul transporter designed and built specifically for this purpose. At the storage facility, the heavy-haul transporter is aligned with the concrete fuel storage pad. Using inflating devices under the storage cask, the cask is raised slightly and guided to its location on the fuel storage pad. When the cask is in place, the inflatable pads are removed and the cask is hydraulically lowered to the concrete storage pad. The vents that allow air in to cool the outside surface of the sealed fuel canister are covered with screens to keep out leaves and small animals. The air that enters these vents exits through a screen vent at the top of the storage cask, where the temperature is continually monitored. Although routine radiation readings on and around the casks will be taken, air temperature monitoring can provide preliminary information in the event of a change in the integrity of a fuel canister. Each fuel transfer operation takes approximately 8 days to complete, but the work doesn't end there. The casks and fuel storage facility will continue to be guarded 24 hours a day by security equipment and personnel until the fuel is removed by the federal government.
Dry cask storage is a safe and reliable interim fuel storage method and used at numerous facilities across the country. At Yankee Row, it will facilitate the completion of decommissioning, save electric consumers money, and prepare the fuel for shipment. But the ultimate solution is to remove the fuel as planned to a centralized federal facility where it can be monitored and protected long term. We will continue to urge the permanent removal of Yankee's fuel so that the Yankee Row site can be made available for other uses.